All right, we're going to look a little bit at notation here. So functions can be written as a rule, an equation that just simply links inputs and outputs. When written in function notation, we replace y with f of x. So back in the day when you first learned this stuff, we may have seen this written as y equals x squared minus 4. We are now just replacing the y with an f of x because we want to give that function x squared minus 4 the name f. Its name is like Frank, okay? It may be helpful to think of a function as a machine. You basically have your input values for x that you are feeding into this machine. All right, so you're replacing x with some value, and then you get an output, and that's basically your y value. So we've got numbers are plugged into the function for x. These are the domain. The resulting outputs are the values for y. These numbers are the range. So let's look at some notation practice. So in this table here, we are given a function. We're told what the input is. We're then going to replace this x with the value of 2. So this 2 replaced the x because it was f of x. And then in the function where that x is, we're going to replace that x with a 2. And then we just evaluate. So what we end up with is when you take the function f and you plug 2 in, the output is 7. So if we write that as an ordered pair, x is 2 and y is 7. Okay. So with this first example here, we're being asked for h of negative 2. So we're going to replace all the x's, there's only one, with negative 2. So I'm going to put negative 2 in there, negative 2 squared minus 3. So we have h of negative 2 is equal to negative 2 squared. That's negative 2 times negative 2, which is a positive 4, minus 3. So h of negative 2 is 1. So when my x value is negative 2, the value of the function h is 1. Okay? Go ahead and try the next one on your own, and I will provide you the answer. If you plug negative 4 in for x, the result is 3. So g of negative 4 is 3, and you can write it as an ordered pair. So we can also find the input value to a function for a particular output. So here we're given the function f, right? And over here it says find x, so that f of x is equal to 21. So f of x is 21. So if you think about just replacing f of x, we're going to put a 21 there. Okay, most people don't like to write equations like that, so I typically write it like this. Negative 2x plus 7 is equal to 21. I put the value over there. Okay, I'm going to make my pen a little thinner. So here, we just solve, and this is your basic algebra. Right? So we divide by negative 2, and x is going to be negative 7. So what this is saying is that when you have f of negative 7, when x is negative 7, the output of the function is 21. Okay, as an ordered pair, it looks like this. Okay, so different ways that you can write the notation. All right, go ahead and try the next one, and I will provide the answer. Okay, so pause. All right, so we've got that worked out for you, right? We've got the answer here. F of 16 is equal to 4. So let's take a look at some problems in context in this function notation. All right, so let's go ahead and read this. Example 4, let f of t be the outside temperature, sorry, I can't see, in t hours after 6 a.m. Okay, t is the number of hours after 6 a.m. Right, let's go ahead and make sure we underline that and really understand that. Explain the meaning of each statement. So f of 0 equals 58. So 0 hours after 6 a.m. Oh, so that is at 6 a.m. When the time is 6 a.m., the temperature, right? F of T is the outside temperature. The temperature is 58 degrees. The temperature is 58 degrees. All right. This is 6 hours after 6 a.m. So 6 hours after 6 a.m. Oh, that's 12 p.m., noon. When the time is 12 p.m., the temperature, F of T, is 77 degrees. All right, this one here, F of 7 is less than F of 9. Interpret the statement in plain English. So F of 7, that's meaning the temperature 7 hours after 6 a.m. Okay, so 7 hours after 6 a.m. is 1 p.m. 9 hours after 6 a.m. is 3 p.m. So the temperature at 1 p.m. is less than the temp at 3 p.m.